students, today we are going to discuss the topic mathematical reasoning. It is very important with respect to JEE mains. One question should be given in JEE mains. So the topic is mathematical reasoning. Okay. Mathematical reasoning. This is the one of the easiest topic related to the JEE mains. Let us discuss now. What is mathematical reasoning? So this is the very important topic which is an application for the engineering also. Now we are discussing the topic about mathematical reasoning. First let us see the definition of the mathematically acceptable statement. What is mathematically acceptable statement? That is, what is meant by a statement? First of all, we are discussing about the mathematical statement. Mathematical statement, it is nothing but a sentence which is either true or false, but not both. So, this is the statement. A sentence is called mathematically acceptable statement if it is either true or false, but not both. So, if you take any statement that is either true or false, then only we say that it is mathematically reasonable statement. So that is the sentence which is either true or false but not both. Let us see the example. Plus 2 is equal to 4. This is always true. So if you take 2 and add the 2 to another 2, 2 plus 2, that is 4. Clearly it is true. So the output is true. Therefore the sentence is mathematically acceptable. So it is truth statement. That may be true or false but not both. So it is one of the statement. Next one, all prime numbers are odd numbers. This is the next statement. All prime numbers are odd numbers. We know that 2 is also prime number. So this statement is wrong statement. This is correct statement. This is wrong statement. Clearly we can decide whether it is true or false. This is truth statement. This is false statement. Let us see another example. Everyone in India speaks Hindi. This is false statement. Some may speak Hindi, some may not be speak Hindi. That is why this is also a wrong statement. Now let us move for another statement. The sum of all interior angles of triangle is 180 degrees. Clearly it is truth statement. This is correct. Mathematically correct. So if you take any sentence, that is whether it is true or false, we say that it is a mathematically acceptable statement. Let us move for another example. New Delhi is the capital of India. As correct, New Delhi is the capital of India. That is why it is correct statement. So this sentence is correct. So output is correct. Now let us see these examples. The square of the integer n is an even integer. Square of an integer. Square of the integer n is an even integer. Sometimes that may be even or may not be even. Suppose if you take the integer 3, what is the square of 3? 3 square, that is equal to 9. This is odd integer. If you take 4, this is also an integer. If you square it, that is 4 square, that is 16. This is even. So sometimes our statement is correct, sometimes our statement is false. Therefore, this sentence is not a mathematically acceptable statement. So 3 square is 9 here, 4 square is 16. Sometimes correct, sometimes not correct. That is the following of our sentence. So this is sometimes correct, sometimes false. Therefore, it is not mathematically acceptable statement. So next example. Where are you going? See this sentence. Where are you going? This is question. It is not a statement. So it is not mathematically acceptable statement. Not acceptable statement. These are not statement examples. Now let us see this another example. Open the door. This is question, this is command. This is also not a sentence. This is not statement. Mathematically, it is not statement. See this example. The sum of two integers is greater than 0. Sum of two integers is greater than 0. If you take 5 and plus 3, that is equals to 8. Clearly it is greater than 0. If you take minus 5 plus 3, it is minus 2. Clearly it is less than 0. Sometimes the sentence is correct, sometimes the sentence is wrong. So this sentence is not a mathematically acceptable statement. Okay, now let us go for another example. Mathematics is difficult. So this is the subject, mathematics. It is easy for some of the students, it is difficult for some of the students. So it is not clearly gives the truth result, either true or false. So sometimes it may be correct, sometimes it may be false. Therefore, it is also a not mathematically acceptable statement. Okay. Now, let us move for the another concept. The statements are usually denoted by the lowercase of letters p, q, r. Okay, we discussed what about mathematically acceptable statement. A statement is a sentence which is either true or false, but not both, my dears. So this type of statements are generally denoted by p, q, r small letters. Okay, next. The true or falsehood of the statements is called the truth values. Suppose a statement is there, the result is true or false. The truth or falsehood of the statements is called the truth values. For every statement, if it is mathematically acceptable, then there are two outputs. That one is true or false. So they are called truth values. The truthness of the statements are called truth values. Sun rises in the east. This is always true. So its output is true. So okay, that is why 2 plus 5. That is, if you say it is 8, this is wrong statement. So its output is false. So the mathematically acceptable statement has two outcomes. One is true and other one is false. Next. See here, the truth value of the statement is true. It is denoted by T. It is denoted by T. Truth value of the statement, if it is true, it is denoted by T. If it is false, then it is denoted by F, my dears. The truth value of the false statement is false and it is denoted by F. In this slide, we discussed what about thing is here, the statements are usually denoted by lower letters and the statement is true, it is denoted by T. If the statement is false, it is denoted by F. So what are T and F outputs of that statement? So the truth values of the statements are generally two types. One is T and other one is F, my dears. The next one. What is negation? Negation is defined for truthness of the statement. So suppose one statement is there, mathematically acceptable statement is there. How to define the negation to that statement? Negation, we mean it is not. Negation means what? Not. N-O-T, not. See here, let P be any statement that is mathematically acceptable statement. So it may be either true or false, my dears. The statement it is not the case of P is called the negation of P. So some statement is there. If you add not to that statement, it gives the negation, negativity of the statement. Negation, that means negative sense of the statement. Suppose one statement is there. If you add up not to that statement, you get negation of that statement. So I am reading as the statement, it is not the case that P is called negation of P. Okay. The negation of P is denoted by this symbol, negation of P. We read it as negation of P. Negation of P is read as not P. Sometimes we read it as itself negation of P. Not P or negation of P. Let us see this example. P. Prices are rising. This is my statement. Prices are rising. I am given that the costs are increasing. Prices are rising. This is my mathematically statement. Negation of P means what? Prices are not rising. Here prices are rising is mathematically statement. Its negation we are adding not. So prices are not rising. This is the example. Let us see one more example. P is my statement, mathematical statement. Root 7 is irrational. This is my statement. What is the negation of P? Negation of P is nothing but root 7 is not irrational. It is not irrational. Not irrational. That means root 7 is rational. So root 7 is irrational is my P. Negation of P means root 7 is not irrational. Not irrational we mean rational. This is the negation. Negation of statement is obtained by just including not to that statement. Understand? Next. Negation of P is nothing but not P. Note that negation of P is always P. Negation of P is always P, my dears. Not of not, that is nothing but old statement. Negation of P is your P. Okay. Next one. Truth table. What is truth table? You have the statement. Suppose you have mathematically acceptable statement. So it has possibilities, true or false. The truth values of statement we are putting in the table that is called truth table. The truth table displays the relationship between the truth values of the statements. That's all. The truth table displays the relationship between the truth values of the statements. Suppose P is my statement that has two possibilities. For my statement that may be true or false. Sometimes my statement may be true or false. What is its negation? Suppose my statement is true. What is its negation? False. Negation means not true. Not true means false. False. Your statement is false. What is its negation? Not false. That means what? True. So this is the relation. So the truth table displays the relationship between the truth values of the statements. So in this manner we can prepare the truth tables for the statements. What are logical operators? Let us see the next concept. Logical operators. These are the operators which are used to connect the simple statements. Simple mathematical statements. So operators are nothing but here connectivities. See here, these are used to form a new statements from two or more existing statements. Suppose I have two statements. These two or more statements are connected by the logical operators. Okay. The logical operators are called connectives and new statements are called compound statements. New statements are called compound statements. Suppose two or more statements are there, simple statements. If you add them or connective by these statements, we obtain the compound statements. We get the compound statements. Understand? Let us try to do the examples for this. Then first one is conjunction. So our first connectivity is what? Conjunction. How to define this conjunction? Let us see. Conjunction. See, read this one. P and Q are two statements. Suppose P and Q are any two statements. The statement P and Q is denoted by the symbol P and Q. P conjunction Q is the statement which is defined in this manner such that is true when both P and Q are true and is false otherwise. And is false otherwise. P and Q is my compound statement. This is my compound statement. P and Q are any two statements. P and Q we are defining such a manner that this is always true when both P and Q are true. Otherwise it is false. This is the definition of conjunction of two statements P and Q. When it is true, both P and Q are true, then only true. Otherwise what? It is false. What are the possibilities for P? That may be true or false. What are the possibilities for Q? That may be true or false. So if you club these two, what are the possibilities? True, 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 false, false, true, false, false. These are the possible cases for the two statements P and Q. This is my first statement P, this is my second statement Q. Understand? So these are the four possibilities for that P and Q. Both are true. Our conjunction P and Q is true. This is true. What about true and false? False. This is false. That is why false. This is also false statement. This is also false statement. So the statement P and Q is defined in this manner. This is the output of P and Q. When P and Q are both true, then P and Q is true. Otherwise, the statement is false. In this manner, we define the conjunction that is denoted by in this manner. This is one of the connectivity. So, conjunction is one of the connectivity to connect the two or more statements. We get the compound statement. This is true. P and Q is true if both P and Q are true. Suppose P, Q, R are three statements. P and Q and R is true when only P, Q, R are true. If the three statements P, Q, R are true, then the statement is P and Q and R is true. In other cases, this is false. Okay. Now, this is the truth table. P, Q, P and Q. True, true, true. True, false, false. False, true, false. False, false gives false. False, true gives what? False. True, false gives what? False. True and true gives what? True. In this manner, we can prepare the table. Already we explained. Let us see this example. This is my first statement. Roses are red. This is my next statement. Q. Violets are blue. This is my first statement. This is my second statement. How to prepare P and Q? P and Q is roses are red and violets are blue. Roses are red and violets are blue. This is example. Its truthness depends upon the results. Okay. Next example, see this one. P is equals to 2 is P. Suppose this is the statement P. 2 is root of x square minus 3x plus 2 equal to 0. Q is the another statement. That is 1 is root of x square minus 3x plus 2 equal to 0. What is P? This is the statement. 2 is root of x square minus 3x plus 2 equal to 0. What is the second statement? 1 is the root of x square minus 3x plus 2 equal to 0. Whether it is true or false, leave the output. This is first statement, this is second statement. How to prepare P and Q? And is there. You just put and. That means what? 2 is root of this equation as well as 1 is the root of this equation. 2 and 1. That means 1 and 2 are roots of this equation is the statement P and Q. Statement P and Q gives what? 1 and 2 are the roots of x square minus 3x plus 2. So, if you substitute 2 here, 4 minus 6 plus 2, 6 minus 6, 0. So, this is truth statement. Again, Q is equals to 1. Substitute Q equal to 1 here, 1 minus 3 plus 2. That is also 0. This is also truth statement. Both statements are true. So, if you apply and, the result is also true. So, when you are going to the truthness of these statements, true obtained here. Okay. Right. Next one. This is the next connectivity, disjunction. So, the second connectivity is the disjunction. Already we discussed about conjunction. If both are true, then the result is true, otherwise false. For this disjunction, P and Q are any two statements. P are disjunction, generally it is nothing but it is denoted by like this. Okay, R, disjunction means R. Any one of them is true. At least one of the statement is true, then the result is true. Result we mean disjunction. If you apply disjunction to that statements, the compound statement gives the result true. If at least one of them is true, otherwise false. Otherwise false we mean if all the statements are false, then only their union is false. Okay, let us see. See here, let P and Q be the statements. P and Q are any two statements. The statement P or Q is denoted by the symbol P or Q and is the statement that is false. That is false when both P and Q are false and is true otherwise. Already we discussed the definition. It means what? P and Q, this is result false only when both P and Q are false, otherwise it is true. The statement P and Q is called the disjunction of the statement P and Q. Disjunction of the statement P and Q. This is disjunction of P and Q. If you write in this manner, conjunction of P and Q. Conjunction, disjunction. Okay. This is the truth table for disjunction. P and Q are the two statements. What are the possible outcomes? True, true. P may be true, Q may be true. Both are true. Output is true. Because at least one is true, the output will be true. True, false. The statement P is true here and here it is false. Therefore, true, false. The output is true. Because here is true. False, true. Here is true. At least one true is there. Result will be true. It is true. Here both are false. Both are false. Automatically your result must and should be false. So P and Q are the two statements. These are the possible outcomes. Truth values. Truth outputs. P and Q. True, 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 false. In previously we discussed P and Q. What happened? True and true, then only true. The 3-1 false. So this is the difference. If you write P and Q for the same data, what we obtain here? True and true. This is true. True and false. False. False and true. That is false. False and false. False. Already we discussed the truth table for P and Q. Now this is P or Q. This is the difference between these two. Okay. So this is the disjunction. Let us see the examples. See this one. This is my example. 125 is multiple of 5. Yes. 125 is multiple of 5. 125 by 5. 5 2s, 5 5s. That is 5 into 25 gives 125. So it is multiple of 5. This is my statement. Whether it is true or false, leave it in this manner. This is one of my statement. 125 is multiple of 7. Actually, this is truth statement. This is false statement. Leave the output. This is one of my statement. This is the second statement. How to write PRQ? That means 125 is multiple of 5 or 7. You have to write or. If it is a conjunction, you have to write instead of or, what you have to write? And. This is 5 or 7. This is the disjunction of P and Q. If you want to write their truth values, P is a truth statement, Q is the false statement, and PRQ is a truth statement. At least one of them is true, your statement is true. Understand? So this is truth statement, this is false statement, this is the truth statement, their combined statement. This is PRQ. This is the disjunction. Understand? Next one. Implication. This is the third one. Already we discussed two connectivities. One is disjunction, another one is conjunction, and third one is implication. It is denoted by implies. All of you know the implies symbol. Implies, or we denote in this manner. Implication. Implication, that is if then. Okay, let us see. Let P and Q be the two statements. Here I am going to define the implication. What is P? What is Q? These are any two statements. The implication P implies Q is the statement is false. In implication, P is called the hypothesis and Q is called conclusion. P implies Q is the statement. P implies Q is the statement that is false when P is true, Q is false. We missed the meaning here. When P is true and Q is false, then only P implies Q is false. Truth implies false is a false statement. This is the definition. Implication definition is like this. Truth implies false is false. In the remaining three cases, we have true. That means, suppose P is here, Q is here. What are the possible outcomes? True, 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 false, false, true, false, false. What I am saying, this is P implies Q. Truth implies truth, that is always true. Truth implies false, that is false. This is. Truth never false. Simply think that one. Truth never false. Truth implies false means that is false statement. False implies truth. Sometimes false may be truth. This is truth statement. False is always false. That means false implies false is the truth statement. So true, false, true, true. Truth implies false is only the false statement. In other three cases we have the truth values. Is true. So truth implies false is only false. T, F, F. The remaining three cases you have true. This is the definition of the implication. So implication, it is denoted by implies. If P, then Q. P and Q are two statements. The connectivity is if P, then Q. P implies Q means what? If P is happened, then automatically Q will be happened. That is the meaning of if P, then Q. Okay. Example. P. An integer is multiple of 9. This is my statement. First statement. P is the first statement. See here, this is false when P is true, Q is false. then only the statement is false. The in other cases the statement is true. An integer is a multiple of 9. Q as an integer which is multiple of 3. These are my two statements. This is P, this is Q. P implies Q is the statement. If P implies Q is the statement, if an integer is multiple of 9, then it is multiple of 3. P and Q are the two statements. What is P? It is an integer multiple of 9. Q, it is an integer multiple of 3. How to club this with the implication? P implies Q. We mean what? If an integer is multiple of 9, then it is multiple of 3. Leave the outputs, whether it is true or false, leave them. P is an integer which is multiple of 9. Q is an integer multiple of 3. If P, then Q. It means what? If an integer is a multiple of 9, then it is immediately multiple of 3. Is the combined statement, that is implication of P and Q. So let us check the truth values of the P and Q. An integer is multiple of 9. An integer is multiple of 3. If both are true, then my result is also true. If P is multiple of 9, then automatically Q is multiple of 3, then P is multiple of 9, then automatically Q is multiple of 3. It is truth statement. Understand? Next, this is the truth table. P and Q. P implies Q is there. True, true, true. Truth implies false. False statement. This is one and only case for the false. False, true, that is true. False, false, that is false. This is implication. Okay. And biconditional. Biconditional or by implication. This is the fourth connectivity and last connectivity for the statements. So one is conjunction, disjunction, implication and by implication. By implication is the symbol denoted like this. If and only if. If and only if. In previous we have only if then. Here if and only if. This is biconditional. See here, let P and Q be the two statements. The biconditional P by implication of Q is the statement that is true when P and Q have the same truth values and it is false for otherwise. That means what? Both, suppose these are the two statements. If both have the same output, then only it will be true. Otherwise it is false. P by implication of Q. So true, true, true. True, false, false. False, true. False. False, false. This is truth statement. If both have the same output, then the result will be true. See here, these both are true, that is true. Both are false, that is true. In the other two cases, we have the false. P by implication of Q is the statement that is true when P and Q have the same truth values. Same truth values and it is false otherwise. This is the definition of the biconditional. In this manner we can define the biconditional. So example, an integer n is odd if and only if n square is odd. Leave the output. This is my statement. An integer n is odd if and only if n square is odd. This is the biconditional of the two statements. An integer n is odd, that is first condition, first statement, and second statement is the integer n square is odd. So these are the two statements. This is the combined statement by using the biconditional operator, that is an integer n is odd if and only if n square is odd. Truth table. Let us see the truth table. Same table we are preparing in this manner. P, Q, true, 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 false, 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 true, false, 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 true. This is the table for the biconditional. So in this manner we can prepare the four conditionals, four logical operators. So one is disjunction, conjunction, implication and by implication. These are four connectives which are used to connect the simple statements. We apply the compound statements. So in this session we discussed what is statement, mathematically acceptable statement, how to represent this one, and what are connectives, how to connect them, what are the four types of the connectives, with the help of the connectives, how to prepare the compound statements. In the next session, we will continue the class. Okay, thank you.